All right, today's lesson is 11.2b, where our objective is going to be to divide rational expressions. All right, so that's our goal for the day. We're going to be able to divide rational expressions. The nice part about dividing rational expressions is it's very similar to what we were just doing yesterday, which was the multiplying of the rational expressions. So when we divide fractions, remember that division is the same as multiplying by the reciprocal. Okay, so multiplying by the reciprocal, which basically means that we're going to change our division sign to multiplication, and we're going to flip that second fraction. Okay, and you'll often hear me use the words keep, switch, flip, and what I mean by that is we're going to keep our first fraction as 1 over 4. We're going to switch our sign in the middle to multiplication, and then we're going to flip that second fraction. Okay, so like I said, the words that I'm going to use are keep, switch, and flip. And that's what I'll be saying over and over today as we go through the division process. But then from there, like we talked about when we multiplied fractions, it's often easier to go ahead and simplify before you actually multiply. And the way that we simplify is by going across the multiplication problem. So 1 and 3, those are already simplified, but I have 4 on the bottom left and 8 on the top right. I know 4 goes into both of those. So if I divide 4 by 4, I get 1, and 8 by 4, I get 2. So now our multiplication problem is top times top, bottom times bottom. Well, 1 times 2 is 2, and 1 times 3 is 3. So we would get 2/3. All right, and we can use that same process on the next problem as well. So for the next problem, what we are going to do is we are going to keep the first fraction as negative 10y over 3x. We are going to switch our sign to multiplication, and we are going to flip our second fraction, so it is now 9x to the third y over 11. And then from there, we go ahead and look and see what we can cancel out before we multiply. So for the top left and bottom right, there's nothing really that cancels out because we have a negative 10y and an 11. But for the bottom left and top right, I notice that 3 goes into both 3 and 9. So that's going to turn the 3 to a 1, the 9 to a 3. And I see that I have an x on the bottom here, so that x is going to cancel with only one of these x's up here to turn it to an x squared. All right, so now we just multiply top times top and bottom times bottom. So up top I have negative 10 times 3, which gives me negative 30. I then have x squared, and then I have a y times y, which is y squared. And on bottom I just have 1 times 11, which is 11. And then from there we're good to go. So now we're going to do that same thing where we have polynomials in the numerators and denominators. And so that's very similar to our multiplication steps that we learned from yesterday. We're still just going to do our keep, switch, flip first, and then we'll go ahead, factor, simplify, and multiply. All right, so we keep the first fraction as is. If you want to, you can do the factoring step at this point, but I'm going to break it down a little bit easier. So I'm just going to keep it as is. I'm going to switch my sign to multiplication, and I'm going to flip that second fraction to be x squared plus 5x over x squared minus 4. Now we need to factor these things. So we factor the top left, x squared plus 7x plus 10. Since it has a leading coefficient of 1, I can just go right into my parentheses. Plus plus tells me plus plus. Only way to get to x squared is x and x. And then we're looking for the factors of 10 that add up to 7. That's going to be 2 and 5. The bottom of this fraction we can't do anything to, it's just 3x, so that's going to stay. Keep your multiplication sign in the middle, and now let's factor the purple fraction. So up top I have x squared plus 5x. I see that we have a GCF of x, and If I take an x out of both those terms, I'm going to be left with x plus 5 inside my parentheses. And then on the bottom, I have x squared minus 4. That's one of those special cases. That's our difference of squares, because x squared is a perfect square and 4 is a perfect square. So we should know that it's going to be plus and minus, and we're just finding the square roots of those. So x squared is going to turn into x and x, and 4 is going to turn into 2 and 2. So now what we do is we simplify what we can. And remember, it's only tops and bottoms that cancel out. We can't do both tops or both bottoms. So I have an x plus 2 here and an x plus 2 down here. Those will cancel. I have an x down here and an x up here. Those will cancel. And other than that, that's going to be what's left. So now we just do top times top, bottom times bottom, which we can leave it in its factored form. So x plus 5 times x plus 5 over 3 times x minus 2. Okay? Then on to the next problem. Same idea, we're going to do keep, switch, flip. So keep the first fraction, 5x squared minus 22x plus 8 divided by x squared minus 16. Switch your sign to multiplication and flip that second fraction to be x minus 7 over 10x minus 4. Now we factor. So there's no GCF in the top left, so we just go straight to our parentheses and do our sign analysis. I have a plus sign at the end, which means they're both going to be the same, and the minus sign in the middle tells me both subtraction. Now the only way that we can get to 5x squared is by using 5x and 1x. And then we have the factors of 8 that are going to add up to 22 when one of them is multiplied by 5. So I always tell you to start with the closest ones together. You plug in 2 and 4. Okay, and then again, I always recommend that you guys check that to make sure it works by multiplying the insides and outsides. And then for the bottom, again, this is one of those special cases where we have a difference of squares. So we set up our two sets of parentheses. One's going to be positive, one's going to be negative. X squared splits up into x and x, and 16 splits up into 4 and 4. So now that that one is factored, we can go ahead and do the next one, which we can't do anything to the top, it's just x minus 7. But in the denominator, we have 10x minus 4, so we can factor out a GCF of 2, and we're going to be left with 5x minus 2. Okay, now just like yesterday, anything up top can cancel with anything in the bottom, right? So when you look at that first fraction, hopefully you recognize that you have x minus 4 over x minus 4. Okay, so that cancels out, and now we can start looking across. So if I look at the top left, I have a 5x minus 2. That's going to cancel out the 5x minus 2 in the bottom right. So a lot of cancellation happening here. All we have left up top is just that x minus 7. And what we have left on bottom is going to be 2 times x plus 4. All right. And then on to the last problem for this page. Same exact idea. We're going to go through the same process. Actually, never mind. This one is multiplication, so we don't have to go through that same process. Okay, so pay attention to the signs. Otherwise, you'll end up making mistakes like I was about to. So what we want to do here is just, we can get right into factoring. All right. On the left side, I have x squared plus 1x minus 20. Well, if my last sign is negative, I'm going to add and subtract. Only way you get to x squared is x and x. Now we're looking for the factors of 20 that have a difference of 1. That's going to be a positive 5 and a negative 4 to get us to positive 1 in the middle. Then the denominator is a difference of squares, where one's going to be positive, one's going to be negative. X squared splits up into x, and 9 splits up into 3 and 3. Now we go ahead and we do the second fraction as well. So on the top, we can factor out an x. We're going to be left with 2x plus 3. And in the denominator, when we factor that, there's no GCF, so we just have to go to our parentheses. Our sign analysis tells us that it's going to be 1 positive and 1 negative because it's a negative 12 at the end there. Only way to get to 2x squared is with 2x into x. And then we're looking for the factors of 12 that are going to have a difference of 5 when one of them is multiplied by 2. Okay, so you're probably looking at 3 and 4. And what we would want is we would want positive 3, negative 4. And again, I would have you check that by doing insides. So 3 times x is 3x. Outsides is 2x times negative 4. That's negative 8x. So 3x minus 8x gets us that negative 5x. All right, so make sure you're double checking those, especially the ones with the leading coefficients. And now we get to do what we were doing before, which is just canceling out anything that is the same on the top and the bottom. So this x minus 4 will cancel with this x minus 4. This 2x plus 3 will cancel with this 2x plus 3. But then that's it. So now we multiply the top, and we're going to end up with x times x plus 5. And in the denominator, we keep that x plus 3, x minus 3. All right. So as you can see, the steps here for the multiplication problem that we just did at the end are no different than the steps that we just did for division. Division just adds the one step of switching your sign and flipping the second fraction. Okay, that keep, switch, flip part. So let's go ahead and look at our 3 steps that we talked about of dividing rational expressions. So step number 1 was to rewrite as multiplication. Okay, which I use those words keep, switch, flip. Okay, that's a good little reminder for you, just a simple way to remember it. Then, after you have it rewritten, our second step was to factor. Right, we factored all the tops, we factored all the bottoms. And then our third step was to simplify and multiply. So we simplified first, and then we just multiply by rewriting those things next to each other. All right, that is it for your notes today. Feel free to write a couple sentences of something that you learned today, and then rate yourself from 0 to 4.